Hello students, let us continue the session on arithmetic progression. We shall start with exercise 5.2. First question is, which of the following form an arithmetic progression? Justify your answer. To do that, we need to find the common difference. If there exists common difference, then we can say that the given sequence is an arithmetic progression. In the first one, let us find out the difference. Let me do a2 minus a1. Second term minus the first term will be 0. Third term minus the second term is also 0. Fourth term minus the third term is again 0. In all these cases, there is common difference. And this common difference is equal to 0. Therefore, the given series forms an arithmetic progression. Let us see the second one. Does it form an arithmetic progression? For that, again, I will find a2 minus a1, which is 2 minus 0, which is 2. a3 minus a2, 0 minus 2, nothing but minus 2. In this case, a2 minus a1 is not equal to a3 minus a2. This implies the given series is not an arithmetic progression. Let's look at the next third one. You can look at the third one. a2 minus a1 equal to 1 minus 1, which is equal to 0. a3 minus a2 is 2 minus 1, which is 1. Here, there is no common difference. They are not equal. Therefore, it doesn't form an AP. In the fourth one, a2 minus a1 is 22 minus 11, which is 11. a3 minus e2 is 33 minus 22, which is also 11. There is a common difference. Therefore, this series 11, 22, 33 forms an AP. Let's look at fifth question. 1 by 2, 1 by 3, 1 by 4. Here, what is a2 minus a1? a2 minus a1 is 1 by 3 minus 1 by 2. LCM is 6. So we'll be getting 2 minus 3 in the numerator, which is minus 1 by 6. a3 minus a2, 1 upon 4 minus 1 upon 3. LCM is 12. 3 minus 4 in the numerator makes minus 1 by 12. Here, there is no common difference. a2 minus a1 is not equal to a3 minus a2. This implies the given series is not an arithmetic progression. Let's look at sixth one. 2 square is 4. 2 cube is 8. 2 raised to the power 4 is 16. What is a2 minus a1? Is 2 square minus 2? It's nothing but 4 minus 2 equal to 2. a3 minus a2 is 2 cube minus 2 square. 8 minus 4, which will be 4. And a4 minus a3 is 2 raised to the power 4 minus 2 cube, which is 16 minus 8, 8. Here we have a2 minus a1 not equal to a3 minus a2, which is also not equal to a4 minus a3. This implies the given series is not an arithmetic progression. Let's look at the last sub question of the first main. Seventh one, what is a2 minus a1? It is root 12 minus root 3. Root 12 is nothing but root of 4 times of 3. So 2 root 3 minus root 3. We get it as root 3. a3 minus a2 is the third term, root 27 minus the second term, root 12. Root 27 is 3 root 3 and root 12 is 2 root 3 and the difference is root 3. a4 minus a2, here root 48 minus root 27. Root 48 is 16 3 times, so 4 root 3 minus 3 root 3, difference is root 3. Each time we are getting common difference as root 3, therefore the given series forms an arithmetic progression. Let us look at question 2. Justify whether it is true to say that minus 1 minus 3 by 2 minus 2 positive 5 by 2 forms an arithmetic progression as a2 minus a1 is equal to a3 minus a2. What is a2 minus a1? It is negative 3 by 2 minus of minus 1. We get it as LCM is 2, so minus 3 plus 1 by 2, nothing but, LCM, after taking LCM it becomes 2 minus 1 by 2. a3 minus a2 is negative 2 minus of minus 3 by 2, which will be minus 4 plus 3 by 2, nothing but minus 1 by 2. Since there are 4 terms given, let me check a4 minus a3. It is positive 5 by 2 minus of minus 2. We get 5 plus 4 upon 2, nothing but 9 by 2. Here we have got a2 minus a1 equal to a3 minus a2, but it is not equal to a4 minus a3. Therefore, it doesn't form an arithmetic progression. Question number 3. For the arithmetic progression minus 3, minus 7, minus 11, can we find directly a30 minus a20 without actually finding a30 and a20? Give reason for your answer. Here, let's look at the common difference. Will there be a common difference? Let me find out a2 minus a1, the second term minus the first term. Second term is negative 7 minus the first term is minus of minus 3. We get it as minus 4. a3 minus a2, the third term minus the second term is negative 11 minus of minus 7, which will be again minus 4. Here, since there is common difference, I'll write this as CD equal to negative 4. We all have learned a30 is nothing but a plus 30 minus 1. N minus 1 is 30 minus 1, which is 29D, and a20 is a plus 19D. If you do a30 minus a20, the difference if you take, it will be 29 minus 19. A and A will get cancelled. Will be left with 10 times of D. So 10 times of negative 4, which is equal to negative 40. So we can find the difference of A30 and A20. Therefore, we can find difference A30 minus A20 as 10 times of D, because there is a difference of 10 terms here. So 10 times of -4 will be -40. Have a look at question 4. Two arithmetic progressions have the same common difference. The first term of one AP is 2 and for the other it is 7. The difference between their 10th terms is the same as the difference between their 21st terms, which is the same as the difference between their corresponding terms y. Here, let me consider small letter a as the first term of one AP and capital letter A as the first term of the next AP, second AP. Let common difference be D. Now we shall find the differences of their 10th term. A10 minus capital A10. Their differences will be A plus 9 times of D minus capital letter A plus 9 times of D. It will be nothing but A minus A. The reason is 9D and minus 9D, they get cancelled. We get it as 2 minus 7 minus 5. Similar way, let us find out the differences between their 21st term. It will be A plus 20D minus capital A plus 20D. This will be also same as A minus capital A, which is equal to minus 5. So we can get this result. A10 minus capital A10 will be equal to A21 minus capital letter A21. When we take the corresponding terms, we get this result. AN minus capital AN will be also same as A minus capital A negative 5. Hence, the difference between the corresponding terms of AP, the difference between corresponding terms of arithmetic progression will be same as A minus capital A, nothing but minus 5. Question number 5. Is 0 a term of arithmetic progression 31, 28, 25 and so on? Justify your answer. If I want to substitute the value of an, a, d in the expression an equal to a plus n minus 1 into d, if n comes out to be a natural number, then I can say that an will be the term of the given sequence. So for that, I will consider an as 0. First term will be 31 and the common difference is 28 minus 31, we get it as negative 3. So let me substitute in the equation an equal to a plus n minus 1 time of d. An is 0, a value is 31 plus n minus 1 into minus 3. So we get 0 equal to 31 plus 3 minus 3n. When we transpose, we get it as negative 34 equal to negative 31. Sorry, 3n. So n value will be equal to minus 34 by minus 3. We are getting positive number, but again check properly. It is 11 1 by 3 is not a natural number. When we get n value not a natural number, then we can conclude that an, which is equal to 0, is not any term of given arithmetic progression 31, 28, 25 and so on. Let us take up this question as a last question for today's session. Question number 6. The taxi fare of each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for the subsequent additional kilometer doesn't form an arithmetic progression, as the total fare in rupees after each kilometer is 15, 8, 8, 8, so on. Is this statement true? Give reason. This 15, 8, 8, 8, these are not the total fare. For 1 kilometer, 2 kilometer, subsequent kilometers, because the reason is total fare for first kilometer will be rupees 15. This is correct, but the total fare for second kilometer will be rupees 15 should be added to rupees 8. We get it as rupees 23. This should be the second fare, and the total fare for third kilometer will be rupees 23 added to rupees 8. For the next kilometer, rupees 8 is considered, so it is rupees 31, and the total fare for fourth kilometer will be rupees 31 plus rupees 8, which will be nothing but rupees 39. So 15, 23, 31, 39 will form arithmetic progression, since this series has common difference equal to 8. But given series 15, 8, 8, so on is not an arithmetic progression. Understood? With this, I'll conclude today's session. We shall discuss the remaining questions of the exercise in the next session. Thank you.